Hi there. I'm going to make a quick little video where I just go through my answers to these practice problems. A lot of the discussion may be happening while I'm gone at retreat, so I just want to make a lot of resources available to you. So from section 1.7, it's quick check number 3, and then exercises 3, 5, 7, and 25. So I'll just add a little page here, put this at the end. So for the quick check, it's really just checking that you know basic inverse sine things. So sine inverse of -1, we're thinking of an angle that gives us sine of theta equals -1 in the specified range. That's -pi/2. Inverse tangent of 1, we want an angle whose tangent is 1 in the specified range. That's pi/4. Inverse sine of 1/2 √3 or √3/2. That's pi/3. Inverse cosine of 1/2, also pi/3. And then inverse secant of -2. So secant we don't use a lot, but it's the reciprocal of cosine. So that's basically like inverse cosine of -1/2. So that would be 2pi/3. With secant, it's a little fishy in terms of domain and range sometimes, but I would not really stress over that. This is the best answer. Inverse secant does not literally show up in the AP curriculum, but inverse sine, inverse cosine, inverse tangent are fair game. In terms of the regular exercises, so for number 3, we're just asking where something is continuous. So we have this function. But here's what we want to keep in mind. This function is complicated, but it has a formula. Things with formulas like this are they're continuous where they are defined on their domains. So we have to specify a couple of things here. For this to be defined, we need x² minus 9 is not 0. So x can't be 3, x can't be -3. That's one consideration. We need to be able to take inverse sine of x, inverse tangent of x, but that's okay. Inverse sine and inverse cosine are the ones that are picky about domain. The domain of inverse tangent is all reals. But then, in order to take the square root of that, we need inverse tangent of x to be greater than or equal to 0. So we need to think, what are the values where when we take inverse tangent, the angle we get is at least 0, and those are in fact where x is greater than or equal to 0. So we need all of these things to be true. Specifically, x is greater than or equal to 0. Well, if x is greater than or equal to 0, then x not being -3 we already know. But also x is not 3. So our domain here, so rather where it's continuous on its domain. And we could say that's everything from 0 up to and not including 3, union 3 all the way up to positive infinity. If you just wanted to say all x values greater than or equal to 0 except 3, that's fine. I'm much more concerned with the idea than I am on any specific way of presenting the answer. Number 5, just practicing a little bit with trig stuff. So given that theta is inverse tangent of 4/3, we want to find all of the trig values, so sine of theta, cosine theta, etc. So let's draw a picture here. Basically, what we know is that tangent of theta is 4/3. I could draw a little triangle to illustrate that. Here's theta, 4/3. So look at that 3, 4, 5 triangle. That works out nicely. So cosine of theta is 3/5 just by SOHCAHTOA. Sine of theta is 4/5. Secant is 5/3. Cosecant is 5/4. And what am I leaving out? Cotangent is the reciprocal of tangent, which is 3/4. number 17. So in number 17, we are using a calculator. So we are doing, for part A, inverse sine of 0.25. So when we do that, so I will just, sorry, I'm pulling out a calculator. So inverse sine of 0.25. And that works out to be approximately 0.255449. And then we do the same thing, inverse sine of 0.9. And there's a domain error. This does not exist, it's undefined. All right, so what's going on here? Well, what's going on here presumably is an issue with the domain, right? You're getting some calculator error depending upon how the calculator is programmed, it might be telling you that. Because what happens is, even though 0.9 is in the domain of inverse sine, it might not survive the next step. So that's all part A, actually. And then part B is asking us which values of x could we actually do this for? So what is the actual domain for inverse sine of x? So in order to survive the first step, we need that x has to be somewhere between -1 and 1. Those are the things we can take inverse sine of. But we also need to be able to take inverse sine of that thing. So we additionally need that inverse sine of x is between -1 and 1. Because we are doing inverse sine to that entire thing. In order to be able to do inverse sine to that entire thing, we have to be somewhere between -1 and 1. So then we have to think, all right, well, gosh, what values of x would do this? So we'd think, all right, well, where is inverse sine of x equal to 1? Right, that would be our biggest value. That's basically saying sine of 1 equals x. And that's 1 radian. This is kind of a hard thing for us to think about. But basically, the boundary there would be where we're taking sine of 1 radian. And on the other side, it would be where we're taking sine of -1 radian. So the domain here would be that x has to be somewhere between sine of 1 and sine of -1. Which is the same as negative sine of 1. And we could approximate this on the calculator. So sine of 1 is approximately 0.84. So roughly 0.84147. So in order to do inverse sine twice, x has to be in that interval. And then I think there was one more here, number 25. So number 25 is a limit problem. And we're doing the limit as x approaches 0 of x over sine inverse of x. And it refers us back to the number 24, which says something about invertible functions. Here's what I'm going to do instead. Right, you might have some intuition about this, but I'm going to make a little bit of a substitution. So here's what I'm going to do instead. I am going to say, all right, let's say that sine inverse of x, I will call that t. So what that means is sine of t is equal to x, assuming we're in the correct quadrant and whatnot. No, that's fine. So I'm going to make some substitutions. Let's think about this. If x is approaching 0 and t is sine inverse of x, if I take sine inverse of something close to 0, what kinds of angles give me sines really close to 0? Things that are close to 0. So t is also approaching 0. X, my numerator, is sine of t. Sine inverse of x is t, by definition. So we'll notice if we do this little substitution, this is totally familiar, and the answer is 1. So it's a familiar ratio and a limit presented in a slightly tricky way. So there we go, just a couple of problems to combine some issues of trig and inverse trig with some either pre-calc review about domains or some limit stuff.